Alright, today we're going to discuss kinematics, motion, and graphing. You have done a little bit of graphing motion in class, and so we're going to learn a little bit more and learn about what different graphs mean. The first thing that I want to talk about, though, is kinematics and what it is. What you will need to do is you will need to take these notes down off of these videos and bring them to class with you, and I will take a note score. I want to make sure that you've done these, and then we will have quizzes over these. So you'll need to make sure that you watch the videos and get the notes. Kinematics is the study of an object's motion in terms of displacement, velocity, and acceleration. Sorry about that. At any point in these notes, you can stop, pause them to catch up with me. So let's talk about position. We've been doing some position time graphs. Position is just some location in the universe. So we can graph position, like 40 meters. Let's talk about displacement. Displacement is the object's change in position. Which is different than distance. They sound the same, but they're not. Distance is the amount traveled. So for instance, let's just consider you have second period in the science hall. You have third period in the junior hall. Junior hall. But let's say between second and third period, someone accidentally took your phone because y'all's phones look the same or something like that, and you know that that person had a class in the 500 hall. And it was raining. So you go from the science hall, and you don't want to walk through the rain, so you go through the senior hall or the 200 hall. Through the 300 hall, 300, 400, 500 hall, get phone, then head back, the way you came, and into the junior hall. Your displacement is only measured from science hall to junior hall. Distance is everything you traveled, every step you took. That's the difference between displacement and distance. We measure displacement for the most part whenever we are trying to get velocity. Which is what we're going to talk about next. Velocity. The amount of displacement. In a time interval. We have a formula for that. Velocity equals displacement over time. And when we talk about velocity, we can talk about acceleration. Velocity is the speed you travel in a car. Acceleration is how much you speed up or slow down. Push on the gas pedal or the brake. The amount of change of velocity in a time interval. There's a formula for that too. Acceleration equals change in velocity over time. Remember, you can pause this at any time to catch up with my notes. I'm going to go on and I'm going to start talking about what graphs look like. We know what some of these graphs look like because we've done some of them. Graphing motion. Now I'm going to show you not only position time graphs, but I'm going to show you velocity time graphs, and I may show you some acceleration graphs. We'll have to see. Okay. We've got a position time graph, which is displacement. We're going to label it x over t, 0 at the origin, and we have a velocity time graph. I'm going to group these together in some cases. Both of these graphs are going to represent something not moving. So for the position time graph, would be a straight line across. We did one of these in class. It's just sitting there. For a velocity time graph, it's going to be at 0. The next two graphs that I'm going to show you represent an object moving at constant velocity. We've got our position time graph and our velocity time graph. For a position moving at constant velocity, the position time graph is going to be a line with a slope, a linear graph moving upwards. For a velocity time graph, we're going to have a straight line. And then, I'm sorry, moving at constant velocity in a positive direction. I need to add this. This is above the 0 mark. They're both above 0. The next set of graphs, moving at constant velocity in a negative direction. So your position time graph is going to start here and go downward. Your velocity time graph, we're going to need to extend this below t because it's going to be a straight line below t. Next two graphs, represent speeding up in the positive direction. For a position time graph, anytime you have acceleration, you're going to have a curve. So now that's going to become a curve. Speeding up in the positive direction. Notice which way the curve curves. That's going to be important. For velocity now, we're going to have a linear graph with a slope. The next two graphs, slowing down in the positive direction. Slowing down in positive direction. Alright, now your curve. Anytime you have acceleration on a position time graph, you're going to have a curve. Slowing down is going to look like that. Your velocity time graph, it's going to start on the 0 line for velocity, and it's going to slow down to 0. Slowing down, and that should be, yes, in the positive direction that you're slowing down. Your next two graphs. Slowing down in negative direction. Need to make my T line right here now. Right in the middle. For the position time graph, slowing down or speeding up is always a curve. Any kind of acceleration is always a curve. This curve is going to look like this. Your velocity is going to be a linear graph. It's going to start down here, and it's going to head to 0 because you're slowing down. So it's headed to 0. Headed to 0. This one was slowing down, headed to 0. So slowing down means they're headed to 0. It doesn't matter that it's down here in the negative direction. It's slowing down, so it's heading to 0. And your last two graphs are going to be speeding up in the negative direction. Your position time graph is going to look like this. Your velocity time graph is going to start at 0, and you're speeding up, but in the negative direction. So you're going towards like maybe 2, but in the negative direction. The graphs that confuse me the most are the 4 position time graphs where there is acceleration or deceleration happening. So you need to study those probably the most, get them right in your head. You need to know all of these graphs. I will require you to be able to understand the motion of graphs, and there's going to be many segments to them, by knowing these graphs that I have given you. So I would rewrite them many times and understand what they mean. Make flashcards so that whenever you see the picture, you know whether it's slowing down in a negative direction. They're speeding up in a negative direction. So this would be something I would make note cards out of. I will see you on Monday, and I hope that you have a great weekend. Thank you.